Hello, welcome to the ConfD Technical Introduction. In this module, we'll be taking a look at the basics of ConfD. You'll get introduced to its features and benefits along with an introduction to its architectural features. So first off, what is ConfD? ConfD provides a data model-driven management plane framework which provides a variety of standards-based northbound interfaces for use in building network elements. No matter whether you're doing a physical network device, a virtual device, or a VNF for use in NFV, a network appliance, ConfD can provide all of your management needs for implementing your network device. The idea of ConfD starts with a data model. With the data model, we describe the management information needed for the system, the configuration data, the operational state data, actions, etc. ConfD then uses this data model to automate and drive its processing. This is in contrast to your normal, traditional way of doing network element management in the past. Previously, when you were implementing management for network elements, you were more protocol focused. You would get an SNMP agent, a CLI parser, a web server, etc. For each of those different management interfaces, you would separately implement the instrumentation and data for those interfaces. You couldn't end up sharing back-end information, or if you could, it was very difficult to do. As a result, you ended up with stovepipes or smokestacks of implementation. If you'd implement something for, say, your CLI, you may not have time or resources available to also make it available, say, via SNMP. In today's world, that just does not cut it for getting your device to market. ConfD's approach helps accelerate development of your network element. ConfD's approach is data model driven. First, in ConfD, you start by writing a data model using the Yang data modeling language to describe that configuration data, that operational state data, administrative actions, validation constraints, etc. Then ConfD automates that data model in order to save you writing lots of code. Your code that you write is instrumentation to ConfD simply in terms of the data model, and that common instrumentation is used across all of the northbound interfaces by ConfD. This easily allows you to quickly support new management protocols, react to market changes, and not have feature lag between your management interfaces. The core engine of ConfD does that automation, runs transactions, and we'll learn a lot more about it later in this module. So first off, we'll start with what I call the 50,000-foot view of ConfD. So first off, at the center is the core engine. This is really the heart of ConfD. This is where we'll end up seeing transactions, AAA support, validation, etc., with much more detail on a later slide. ConfD has available a variety of northbound interfaces: netconf, SNMP, Juniper and Cisco CLIs, REST, and also a web interface. With the free version of ConfD, you have netconf and a CLI available for use during development only. With the premium version of ConfD, you have all of the different northbound interfaces available. ConfD also provides a pre-integrated database, which we call CDB, which allows you to store configuration data, optionally operational data. Your applications will interface to that through the Managed Object API. Also, you can instrument through the Data Provider API and make use of an external database in addition to or instead of the CDB database, which is included with ConfD. Now, an important part of ConfD is the data model. In the data model, that is actually loaded by ConfD at runtime. When ConfD starts up, it will load your data models, and from that, drive the core engine. We will automate everything we can off of that data model. Probably the most visible thing is what we call the auto rendering of the management interfaces. You can write a Yang data model, start up ConfD, and immediately log into a Cisco CLI, a Juniper CLI, use netconf, etc., interact with data stored in the ConfD database without having written any software through that interaction. The data model is used to drive validation, it's used to drive schemas of the database. In other words, anything that we can formally describe in the data model, ConfD will automate as much as possible to save you from writing code to do so. So, ConfD is truly data model driven. There are information models out there, languages such as SID or UML. These are important for communication between domain experts. However, those still need mapping to the actual data models. The data model is concrete. It actually describes the organization of the data, the types of the data, the relationships between the data. It actually means something in reality. So the core engine, as I mentioned, is driven by a Yang data model. With ConfD, we have a programmatic model. There are no stubs. You aren't just generating bunches of skeleton routines that then you're spending time filling in. We're automating off the data model, and then you programmatically interact with ConfD in terms of the data model. With, as I mentioned previously, from that data model, we'll render the CLI, render the web interface, drive the database, etc. So for that data modeling, we use a data modeling language called Yang. Yang is standardized by the IETF in RFC 6020. It comes out of the world of netconf, and in a subsequent module, we will do a full Yang tutorial to help you understand more about it. Yang is a very concrete, precise, and semantically rich language. It is designed for readability. When we were designing the original requirements that the Yang data modeling language had to meet, readability was one of the key features that was recognized and identified. Because if you think about it, the number of readers of a data model is much, much greater than the number of writers of a data model, which is much, much greater than the number of data model parser writers out there. So readability is key because we're communicating the management data of our system and its constraints. Yang is modular. It allows you to decompose and write your modules and submodules however best fits the design requirements of your system. It is designed to be an extensible language. There are parsing tools out there that you can use to support extensions or implement, if you so wish, things such as code generation using a tool called Pyang, which is included with ConfD, and we'll see more about Pyang in a subsequent module of this series. So, I've been talking about data modeling. I've been talking about Yang. We will have a full tutorial on the capabilities of Yang in a later module in this series, but just to give you a little example of what Yang looks like, we have a couple slides here that we'll go through that explain this. First off, we see this starts with a module and a namespace and a prefix declaration. This is actually maps to concepts in XML if you're familiar with XML. Yang is actually an XML schema description language, even though it doesn't look like it. It does map to one-to-one to XML, because as I mentioned previously, it comes from the world of netconf, which is an XML-based protocol. So we have the idea of things such as namespaces, etc. In fact, if you've worked with XML or XML schema before, a lot of the concepts are quite similar. We have the idea of importing or including from other modules. We have the ability to do type declarations. In fact, if you're familiar with XML schema and simple types, a Yang type def is pretty much the same thing. We take an existing base type, we apply constraints to it, and then that type can be used later in our model. One of the things we'll see about ConfD is things such as this type def with these constraints, such as length requirements or pattern match requirements. ConfD actually automatically enforces these, which this means is all syntactic validation is described in the Yang data model, and ConfD enforces that. A little bit more of Yang. The key statements to hone in on this slide are leaf, container, and list. These are pretty much the core three statements of Yang. That once you understand these, you can start actually looking at Yang models and understanding them. A leaf, such as this leaf called odd here, has a type. It actually holds data. A container is used to organize the tree. As I mentioned, Yang is an XML schema description language, and as you know if you're familiar with XML, XML is tree-based or hierarchical-based. So container is used to organize that tree or graph, and a leaf is an end node in that tree or graph that holds data. The other key statement to know is list. You can think of a list in Yang as equivalent to a table. A list has entries, and those entries you can think of as rows in a table conceptually. So when you declare a list, such as this list called IFC here, you'll declare keys. These you can think of as key columns in a table, and then there'll be the remaining columns from the table described in your list description in Yang. Another example on this next slide of another list here called labels. The main thing to highlight from here are these use of these statements called must. One of the first things many people will ask when they look at Yang is, why Yang? Why did we invent it? Why didn't we just use something that exists? Well, a key thing here is Yang not only describes the syntax of the data, its organization and its types, it gets into the semantic world, and you can describe semantic relationships between data using Yang. The must statement is one of those key areas. Must allows you to select different data and express a constraint through them. So one must statement here we see based on this path that we're enforcing that the labels can't be the same as an existing interface name, and also that all labels must be unique. We'll get more into the must statement, and this is actually XPath syntax used in must. We'll get into that more in the Yang tutorial module, and also in a later module that focuses specifically on using must for validation with Yang. But for now, this provides you a nice short flavor introduction of Yang until we get more in depth in it in a later module. So moving on, let's dive more now into the capabilities of the ConfD core engine. The core engine is really the heart of ConfD. If you look at traditional network management implementations, your protocol implementations and your protocol agents really are just the tip of the iceberg when it comes to implementing your full management plane. You know, your protocol agents are typically maybe 20% of your implementation effort of your management plane. The back end behind those protocols is usually about 80% of that implementation, and that back end is what the core engine provides. It provides your transaction support, your session management, your authentication, authorization, and auditing for AAA, validation, rollback, etc. With ConfD, first off, transaction management is extremely important. The idea of a transaction is critical to implementing a powerful network management solution. With transactions, we start at point A and we go to point B. We succeed or we fail. If we're making 20 settings as part of that transaction, all 20 of them are going to succeed or all 20 are going to fail. We're not going to have to write code that we worry about what if step 1 fails, what if step 2 fails, what if step 3 fails, how do I back that out? Transactions give us robustness and stability in our system. We succeed or we fail. We avoid that unknown intermediate inconsistent states. It also makes writing our software code on the back end easier because we have the transaction system in place. At the heart of ConfD is that transaction engine. All configuration changes which go through ConfD are transactional. Whether we're using a transactional or a non-transactional user interface, it is still a transaction when it goes through the core engine. In addition to transactions, which are a major feature, ConfD provides a full implementation for your AAA system for authentication, authorization or access control, and auditing. In a subsequent module in this series, we'll go much more in-depth into the AAA system, but as a brief introduction, you have a variety of options available. Authentication can be done internally by ConfD, or it can be done externally. For external authentication, ConfD has out-of-the-box integration with Linux PAM, or Pluggable Authentication Modules, a standard authentication architecture in the Linux operating system. We also provide an external authentication API that you can use to access other types of external authentication. Similarly, as part of your link-in for things such as SSH to netconf or CLI, there are internal SSH server that can be used with ConfD, or we also provide support for using an external SSH server such as OpenSSH. Once you've authenticated into the system and you've allowed someone in, you want to be able to control what they can do through the authorization system. This is where the authorization system of ConfD comes into play. We, for authorization in ConfD, implement role-based access control. So when a user accesses the system, that user is assigned to a role, and then the authorization system provides access control based on which roles they are associated with. For those of you familiar with the Unix or Linux operating system, you can think of as a role as being a Unix group. The authorization system in ConfD is based upon NACM, the netconf access control model, with extensions for the other Northbound interfaces. The third A of AAA is audit. ConfD provides a support for a wide variety of audit information and also destinations for that audit information. You can select different audit levels for different users for what to record for what they've been doing in the system. That information can be sent to a simple file in the file system. It can be sent to a syslog server, or there's also an API available that your code can attach to, receive the audit information, and format it or send it to wherever it needs to go. ConfD also provides support for redundancy or replication of your management data for use in a high availability system. In a couple of slides from now, I'll talk much more about the replication support of ConfD. Also in ConfD is validation support, both syntactic and semantic validation. This is automated validation from the Yang data model. Earlier I mentioned things such as the type def could be automated. Those must statements that you can use to express semantic constraints among your data, that can also be automated. So any syntactic constraints that are described in your Yang data model are automatically enforced by ConfD at data entry time. Semantic constraints such as must constraints, enforcing uniqueness in lists, etc., is done as part of the validation state of transaction processing. We highly automate from the Yang data model all the validation that we possibly can in order to save you from having to spend development time writing and testing code to do that. However, at times you'll find in your system validation constraints that you need that may not be possible to express in Yang or may not be efficient to express in Yang. In that case, we provide a validation API where you can register additional validation handlers, which we'll call as part of validation handling, as part of transaction handling. An important part of the transaction-based system is, of course, also rollback management. Sometimes you may have been reconfiguring the system, but you need to undo transactions, revert your configuration to a previous point in time, ConfD provides that rollback support. One of the nice things about ConfD is your instrumentation code does not need to know it's a rollback. All they see is a transactional configuration change, because the rollback implementation in ConfD will take the rollback information, populate a new transaction, and that transaction can then be edited or committed, and your instrumentation just sees a transactional configuration change that happens to take it to a previous configuration in time. ConfD also provides support for upgrades and downgrades. Your data models can be changed. To ConfD, it's a data model change. To you, it may be an upgrade, it may be a downgrade. To ConfD, it's a data model change. Those data model changes will be automated to drive schema changes in the CDB database, as well as re-rendering northbound interfaces. ConfD provides support for both cold restart data model changes and also hot in-service data model changes as necessary. Also, there are a variety of APIs for adding instrumentation into your system for ConfD. At the top of the slide, you see the Management Agent API. This is available so that if you need to add additional northbound management interfaces, or you have applications that need to drive transactions, access data, etc., they'll go through the Management Agent API, also sometimes called MAPI. I have already mentioned the Validation API and Authentication APIs. There's also, for the database, the CDB API and the Operational Data API. These are used when your applications need to read configuration data from CDB, subscribe to configuration data change notifications to be told if configuration's changing, or you may also, through the Operational Data API, write operational data into CDB. There is also operational data that you can instrument through the Data Provider API. These two different methods of doing your operational data provide a push method and a pull method. You can independently in your data model describe what operational data is pull mode, what is push mode. And for push mode, your application periodically writes that data into the CDB database, and if a read request comes in for that data, we satisfy it from whatever is currently in the database. In the pull model, that is implemented via the Data Provider API. You'll register callback functions through the Data Provider API, and when someone goes to read that data, ConfD will invoke your callback functions and ask to provide your code to provide the current value for that data. So you can think of it as a cached mode or a real-time mode that's available for implementing that operational data. And again, it's up to you for how you want to instrument it. ConfD provides flexibility. In your data model, you'll add annotation statements that tell us what mode it is, etc. The Data Provider API is also used if you're going to use an external database in addition to or instead of the CDB database, and that is implemented through the Data Provider API. We'll have an entire module on each of these different APIs later in this series to help you understand how to write code to use these different APIs. Now, let's take a look at how ConfD architecturally runs in the operating system. So in this slide, first off, in the upper left, we see the ConfD daemon. This is actually a server daemon process. ConfD runs in the system in a client-server fashion. The ConfD daemon is the server process. Your applications are clients that access that server daemon. So ConfD is running as an independent process. You aren't introducing code into that process. Instead, your application software is interacting with our API libraries, which will then make those client requests to the server daemon. Now, you'll see in these slides the applications and the API library. What that library is doing is taking your API calls turning it into an IPC message back to the ConfD daemon, getting the reply, presenting the API return code to your application. That IPC messaging between the library and the daemon is standardly conducted over a TCP socket. This allows the system to easily distribute, whether you're doing a simple one CPU basic network device or a very large redundant chassis system. ConfD scales and fits any of those needs. Your applications can be running locally with ConfD, or they could be off on a line card, an application blade, another system, as long as there's TCP connectivity possible so that the library can communicate with the ConfD daemon. This architecture, besides giving us a lot of flexibility and functionality that we can use across multi-CPU systems, also allows us to support multiple languages. ConfD includes libraries for the C, Erlang, Java, and Python languages. With the free version of ConfD, the C and Erlang libraries are included. With the premium version of ConfD, you also get the Java and Python libraries. You can have some code written in C, some in Java, each using their own library, talking to the same ConfD daemon. So if you have a requirement for multi-language development, ConfD easily supports that. Additionally, ConfD includes various utility programs or command line options that can be used for scripting and accessing ConfD as well in that mechanism. Now, high availability. Many systems out there need to be redundant for 5 nines, 6 nines reliability, where you'll commonly have a active management card in your system and some number of standby management cards in case of failover. What ConfD focuses on for high availability is replication of the data. You can have in ConfD, we support 1 to n replication, so you can have one active ConfD and any number of standby ConfDs running. As transactions commit onto the master ConfD, those configuration change transactions will be replicated to any standby ConfDs. There are various options available for implementing this replication. It can be synchronous or it can be asynchronous. Asynchronous replication, a change comes in, ConfD forwards it to the standby and moves on. It's basically fire and forget replication on the theory that a problem at the standby node should not affect the active node. In synchronous replication, the active will send the replication to the standby and then wait for a positive acknowledgement from the standby before completing transaction processing. The synchronization check occurs when a new standby ConfD attaches to an active. First, a check is done that the standby is running the same version of ConfD. It's using the same version of data models. And then a simple check of what's called the transaction ID from the CDB database is done. This check reads the transaction IDs from both databases, the active and the standby. If they're equal, we know we're in sync and we then proceed. If the transaction IDs are not equal, then we know the databases are not in sync and the synchronization process needs to occur, in which is done by simply moving the data contents from the active database to the standby, queuing up any transaction changes that may occur along the way. Now, in the world of high availability, what ConfD focuses on is preserving the configuration data. ConfD does not provide your high availability middleware services such as master election, failover control, etc. That needs to be done by external high availability middleware, of which there's various options out there available in the market, as well as many companies have their own in-house high availability frameworks. ConfD provides control and monitoring APIs that get integrated to your high availability middleware in order to then have that middleware control ConfD, tell ConfD is it the active, is it the standby, various other configuration options. Then there are also monitoring APIs so that your high availability middleware can monitor ConfD, receive reports such as a new node joining the high availability cluster, or perhaps we've lost our heartbeat on the replication link, or lost a connection. These are all sorts of things are all reported through a monitoring API that allows then the HA middleware framework to react to those changes. ConfD has been used in a wide variety of carrier-grade systems that require carrier-grade scaling and carrier-grade high availability, and ConfD can meet your need, any of the needs your system may have in this area. Now, let's talk some more about the CDB database, which is included in ConfD. A subsequent module will get much more into the theory and operation of CDB, as well as the capabilities in working with the programming APIs for ConfD. So, first off, CDB is a hierarchical database. It's tree-shaped. It is not a standard relational database of a flat hierarchy of tables. It is a tree-shaped or hierarchical database. As you'll recall, I mentioned that Yang is a XML schema description language. It's describing a tree or a hierarchy. So having a hierarchically organized database with the schema of the database driven by the Yang data model has a lot of benefits and saves time. If we were trying to map to a relational database, it's not so natural. It would take a lot more implementation effort, so that hierarchy goes along well. The CDB data stores for configuration data are transactional data stores. So in the world of transactions, we have this concept of the acid test, or atomicity, consistency, isolation, and durability. These are the four characteristics which a transaction must meet in order to be a transaction. It's atomic. It succeeds or it fails. It's consistent, meaning no matter what order things are populated in the transaction, the same thing happens, meaning all paths from A to B are equal. A transaction happens by itself in isolation. It's also persistent when it occurs. CDB is a binary database. It is not storing things as XML instance documents internally. It's hierarchically organized binary. It maps in an analogous fashion to the idea of XML, but it is not storing XML instance documents. This is important for performance and scalability. CDB is a memory resident database. It is all the contents of CDB are stored in memory for fast access. CDB contents are written to the file system for persistency. For those writes to the file system, like any modern database, CDB is appending journal entries to a file in the file system and periodically rolling up that journal with background processing possible for that. As I mentioned earlier, the schema of the CDB database is automatically driven by the Yang data model. So if your data model changes, ConfD and CDB will undergo an upgrade transaction to upgrade the schema of CDB, along with allowing you an ability to participate in that upgrade transaction. As mentioned previously, CDB supports one-to-end data replication for high availability environments, and we've talked about a little about upgrades and downgrades already. CDB can hold some or all of your data. As we as I mentioned previously, you may use an external database with ConfD in addition to or instead of CDB based on what works best for the design and implementation of your particular system. Now, CDB has other features such as automatic loading of initialization data, meaning when you first start up ConfD and it's first creating CDB, you have the capability of providing XML instance documents that we'll use to initialize the contents of CDB. This allows you to provide things such as factory default configurations. These initialization files can also be used as part of the upgrade process, as we'll learn in a subsequent module. Your applications, how do they actually interact with CDB? We'll get much more in depth of this in a subsequent module, but typically your application comes up, reads its initial configuration data from CDB, and then places what we call subscriptions into CDB. In a subscription, your application is telling ConfD and CDB, if this particular area of data changes, please send me a notification that the data's changed so that I can react to that. These subscriptions, that when you place them, you give us a priority level. With transactions, things are orderless. As I mentioned, all paths from A to B are equal. No matter what order someone populates that transaction, the same results occur. However, in the back end of your system, you do need some control in providing ordering of these changes for the system to occur. So these priority levels are used for ConfD to notify your applications in a order that you control with your instrumentation. You can have multiple applications at the same priority level that we will notify in parallel, but once all subscription handlers at one priority level are complete, we'll move on to the next lower priority till all subscribers have been notified and have completed, and then that transaction processing is completed. Now, an important feature to note about CDB that differs from other databases is the idea of you can have multiple data stores within CDB. These are driven by definitions from the IETF NetConf standards, but CDB has the idea of up to 4 data stores internally. Startup, running, and candidate are transactional data stores which hold configuration data. The definitions of startup, running, and candidate are driven directly from the NetConf RFCs. The operational data store in CDB is an atomic data store because the atomic model fits operational data better than a transactional model. So any operational data you write to CDB via the push mechanism goes into the operational data store. There is subscription support for the operational data store, just like there's subscription support for the configuration data stores. So, with that, we've talked a lot about the internals of ConfD. Let's talk a little bit about the available Northbound protocol interfaces. First is the NetConf interface. ConfD's NetConf server implementation, many of you will say NetConf agent. In the precise standards terminology, there's a NetConf server and a NetConf client. The NetConf server is the agent that is in the network device. The NetConf client is the management software that is in your management station or orchestration solution. NetConf has currently both NetConf 1.0 as defined in RFC 4741 and NetConf 1.1 as defined in RFC 6241. ConfD fully supports both versions, and you have configuration control over which versions you want to make available from your device. We've done a full implementation of NetConf. We've provided many interoperability tests with other implementations. Also, TLF is extremely active in IETF, helping to author or edit many of the drafts and RFCs in both the NetConf and the Yang worlds. Some of the key features of NetConf is it's designed from the ground up with security in mind. It's most commonly carried over SSH. NetConf is an XML-based protocol. It's actually what's known as an XML RPC style protocol, in which the NetConf client will send an RPC request to the NetConf server in the device, which will reply with an RPC reply. A subsequent module in this series provides a much more in-depth NetConf tutorial. An important idea in the world of NetConf is a strict separation of configuration data from operational state data. In the Yang data model, you declare what is configuration data, what is operational state data, and with NetConf, you can work on just configuration data. In the world of things such as SNMP, this concept didn't exist, and it was realized that it was very important to have support for. So with NetConf, you can do things like the get config operation, which will return only config operation. Otherwise, if you use the get operation, that can be used to get both config and operational data. But separating out what is config data from what is operational data allows you to easily extract configuration from one device, modify it if so desired, and then apply that configuration to another device from your centralized management systems. The ConfD NetConf implementation supports various NetConf RFCs and drafts. Not all of them are listed on this slide. For full details, please consult the ConfD User's Guide. But we support things such as the Notifications RFC, the Partial Lock RFC. Additionally, we're providing support in ConfD for various IETF standard Yang data models, including instrumentation. NetConf is a very important protocol. It is starting to become now required more and more by service providers as part of the network infrastructure. It provides important configuration management features. These we'll dive into more during the in-depth NetConf tutorial module. ConfD provides a full-featured SNMP agent in the premium version of ConfD. The SNMP agent supports V1, V2C, and V3 of the SNMP protocol, supporting all operations. You can, do puts, you can do gets, you can generate traps and informs, etc. ConfD includes the MIBs that are involved with running the SNMP agent, things such as USM, VACUM, target MIB, community MIB, etc. Things such as instrumentation MIBs, such as, say, MIB2, IP MIB, interface MIB, etc., are implemented externally from ConfD and are provided via other add-on solutions for ConfD. An important thing about the world of SNMP is, of course, there we have MIBs. How do we bridge from the SNMP MIB world to the Yang data model world of ConfD? ConfD includes tools that allow you to do this. With ConfD, we provide tools where you can take a MIB and from that MIB generate the appropriate Yang data model. We also provide tools where you can start from a Yang data model and auto-generate your enterprise MIB from that Yang model. So at the heart of it, the SNMP agent in ConfD is really bridging from the MIB OID world into the Yang world used by ConfD. ConfD also includes a CLI agent. In the free version of ConfD, only the XR CLI is available, only one session and only for use during development time and not production time. In the premium version of ConfD, it's an unrestricted CLI that can be used for production and has available the Cisco iOS style CLI, the Cisco XR, sometimes called IOX CLI, as well as a Juniper Junos CLI. It's an extremely powerful CLI agent in ConfD that provides rich support for tab completion, history, editing old commands, very easy to extend and add new commands. If you want to add custom commands into the CLI, you can easily drop in via the plug-and-play scripting support or via custom command handlers. There are all sorts of Yang extension statements we've implemented for ConfD that allow you to control how your CLI gets auto-rendered from your Yang data model. In general, we follow the hierarchy of the Yang data model for that auto rendering. So if you have in your Yang container A, container B, leaf C, the default auto rendered command is A, B, C value for setting the value of C. Sometimes you want to drop a node, rechange names, drop into custom modes. All of that is possible and easily customizable when using the CLI agent for ConfD. ConfD also provides support for managing your system via a web browser. This is implemented as a JSON RPC API. This allows you to have full freedom of choice in the tool sets and frameworks that you use for implementing your web UI content, as well as preserving existing web management content you may have had from a previous generation device or a previous legacy device. The JSON RPC API allows you to fully interact with ConfD for accessing data, whether it's reading data or writing data. You're able to run configuration change transactions, trigger rollbacks in the system, request validation of transactions, execute administrative actions. Also, you can access data model schema information via the JSON RPC API. This allows you to implement auto rendering in your web UI content where, based on the data model information, you can render how you wish. ConfD includes an example of how to implement an auto-rendered web UI via the JSON RPC API. This example is meant to be used for example purposes and uses Dojo, but again, you don't have to use Dojo. You could use any tool set or framework you'd like to as part of your web content. And of course, the web supports both HTTP and HTTPS for secure access. The final northbound interface of ConfD is the REST interface. Just like SNMP, Web, and the full-featured CLI, REST is included with the premium version of ConfD. REST is something many people are familiar with from programming in the web services world. It relies on the verbs of the HTTP transport layer. REST is not a standardized management protocol. REST is a technique. So we need to standardize how do we map from REST operations such as get, push, post, etc. How do we map these operations into the world of Yang and ConfD? So, basically get will be used to get resources, put will replace existing resources, etc. So these various HTTP verbs are mapped into operations in the system, and then based on parameters that come in with the REST request, those get mapped into the data model. REST provides a stateless client-server interface into the system. So essentially each REST operation ends up getting mapped into a transaction, because with REST, since it's stateless, in fact the S in REST stands for stateless, you don't have an ongoing multiple put transaction. One put is one transaction in the system. The REST interface of ConfD supports XML or JSON implementation, and essentially your URIs that you work back and forth with provide links to available data stores and operations. You can query, walk down the tree, find resources that are available, and interact with them as necessary. So, in summary, why ConfD? ConfD enables you to make your device easily manageable via a variety of northbound interfaces, giving equal access to your management data. It's a programmable system. It's easily extended. We don't dictate how your system is implemented. You can implement it as you wish. ConfD is implemented based on industry open standards, and as standards evolve, ConfD evolves to meet those new standards. And it's not following the standards, it's helping set the standards, because at TLF we're highly involved with the standards bodies that are writing the standards being implemented. ConfD provides a full set of northbound management interfaces: netconf, CLI, SNMP, REB, and WEST. We support transactions and rollbacks, validation, configuration, etc. It saves you time. Not only do you have all these features that your customers want for managing your equipment, it saves you time in developing and getting to market with your equipment by automating things, by being model driven and automating things such as rendering the core, the management interfaces, which then you customize and extend. Also, ConfD fits very well with iterative development. In other words, an agile development method. You write a little bit of Yang data model, you add some instrumentation, you're accessing it via your management interfaces, you grow your data model a little bit more, you grow your instrumentation a little bit more. So very easy to adopt ConfD to an agile development process. ConfD provides all the core components you need for your management plane of your network device. It provides a pre-integrated embedded database. You don't need to select a database and integrate it into your system. It is designed for everything you need for domain-specific functions for network management. It has a well-designed, rich set of APIs that have been well-tested and used by many, many customers in many different network devices in the field. So with that, I'd like to thank you for listening and watching through this ConfD technical introduction module. This provided many of the fundamental technical concepts you'll need in order to go further in your ConfD learning, and please take a look at further modules in this training video sequence.